Okay, so what we saw here is the necessary conditions are given by this theorem. Okay, so I think everyone is able to see the screen. This theorem tells us about if f dash z exists at a point, then the Cauchy-Riemann equations are satisfied and first order derivatives both exist. This is known as necessary conditions for differentiability, meaning if function is differentiable, then what happens? So this is known as necessary conditions. Is it fine? Have you got what is meant by necessary conditions?
Yes, ma'am.
Okay, so these are the necessary conditions. What are they? F dash z exists means if it exists, then what must follow? The first order derivatives must exist and they should satisfy these are two conditions, these are two equations which are known as Cauchy-Riemann equations. Now these conditions are not sufficient for f dash to exist. Though u, v are differentiable partially with respect to x and y, and though they satisfy Cauchy-Riemann equations, it is not sufficient for f to be differentiable. That is why separately we study the sufficient conditions for differentiability. Already we have seen this theorem also. So let us have a quick look. The statement says f of z equal to u of x comma y plus I times v of x comma y defined throughout some epsilon neighborhood of point z0, and suppose that the first order derivatives of u and v with respect to x and y exist everywhere in the neighborhood. And second thing, partial derivatives are continuous at this point x0, y0, and moreover they satisfy Cauchy-Riemann equations, then surely f dash at z0 exists. I hope you are following me. Got what is meant by sufficient conditions? After what conditions f will be differentiable, that is known as sufficient conditions. So what are the sufficient conditions? U and v must be partially differentiable with respect to x and y. Second thing, the partial derivatives must be continuous at that point. Third thing, partial derivatives must satisfy the Cauchy-Riemann equations. If this happens, then f dash will exist. Means the function will be differentiable. I hope you followed me.
Yes, ma'am.
Okay. Now, the proof of this particular is already given to you. How we, just let us see how we design this proof. We go for the increment delta z. How this increment will take place if there is increment in x as well as in y, I mean real part and imaginary part. So that increment we denote by delta z. Now our function is f of z, and f of z let us denote by the letter w. So delta w means change in the functional value. How would you get change in the functional value? So basically your independent variable must be incremented. So the functional value at the incremented point minus functional value at the original point. This is the difference. So this difference we are noting as delta w. Next we go for delta w. Change will be denoted by change in the real part, change in the imaginary part. This is what we have already done in your notebooks. Now what is delta u? So change in u, how it goes? So u at the incremented point minus u at the original point. Now u is a function of two variables as we are watching. There are two variables, x and y. So x variable is incremented at the same time, y variable is also incremented and the original point you are watching. Same happens with v. Are you following me?
Yes, ma'am.
Preeti, did you got it?
Yes, ma'am.
Okay. So I think you have these things in your notebook. If you keep it in front of you, I think that will suffice. Now, how to get this delta u? Because there are two variables. We go back to the calculus of several variables and we have seen this difference can be written as partial derivative with respect to x into delta x plus partial derivative with respect to y into delta y plus some addition. This addition we say some epsilon 1 into delta x plus epsilon 2 into delta y, where this epsilon 1 and epsilon 2 are negligible, they tend to 0. Here you are watching it. They tend to 0 as the increment delta x comma delta y approaches 0, 0. Same with delta v. You can watch how we talk about delta v. So it is partial derivative of v with respect to x into increment in x plus partial derivative with respect to y into increment in y plus again something is that this part is negligible part, epsilon 3 times delta x plus epsilon 4 times delta y, and this tend to 0, this approach to 0 as delta x delta y approaches to 0, 0. Is it fine?
Yes, ma'am.
Yes, ma'am.
Okay, and all those things we have put in delta w as you are watching. Now in this case, if you remember, we had replaced uy by minus vx and vy by ux, means Cauchy-Riemann equations, and we got the things in terms of only derivatives with respect to x. So you could write this as ux at x naught y naught plus I times vx at x naught y naught and plus the remaining things, and then you divide it by delta z. There you got delta z. I think we took lot many efforts to get delta z there. आपण जेव्हा वर्गामध्ये केलं होतं तेव्हा डेल्टा एक्स प्लस आय टाइम्स डेल्टा वाय आपल्याला कॉमन काढायला बराच वेळ लागला होता, जर आठवत असेल तर एकदा वहीत पाहून घ्या.
हो, मॅडम.
सो हा जो डेल्टा झेड आहे त्याने आपल्याला जेव्हा डिवाइड केलं तेव्हा ही दिस थिंग वी गेट प्युअरली, and in this case you are having delta x upon delta z and delta y upon delta z. But you know better, delta z is nothing but delta x plus I times delta y. So individually when I talk about the real part, modulus of the real part has to be less or equal the real this particular modulus. Same way with this, modulus of the imaginary part will be less or equal. I suppose you are getting me. If not, I would like to go with this is delta z. Okay, just a minute. This helps me. Yes. So yeah, if I talk about delta z, it is nothing but delta x plus I delta y. So what you find is delta x is nothing but the real part. So it being real part, its modulus has to be smaller than the modulus of the original. Are you getting me?
Yes.
And modulus of the imaginary part will also be less than this modulus because it is actually a combination of these two. So we use these facts that modulus of this ratio has to be less or equal 1. Modulus of this ratio is also less or equal 1. So this you have actually written in your notebooks very properly. And then you apply the limit. Then you go for the limit. Just a minute, I am not able to. Yes. So what will happen if you take mod of this particular, this will be less than or equal to mod of epsilon 1 plus I times epsilon 3. but modulus of the sum has to be less or equal sum of the moduli individually. So ultimately where we come to, this part is less or equal. So in your notebooks we have solved it very rightly. This part becomes, this actually goes to 0, and ultimately this incrementary ratio, and when I put limit to this, it becomes this particular. So I would like to go with this. So how we have solved this, we have said, just a minute, annotation I have to on. ठीक है. So what we find here, limit so if I go for limit as delta z tends to 0, if delta z goes to 0, its real part will go to 0, imaginary part also will go to 0. What will happen to the right side of this? This is, you have this in your notebook. So to this side, there is no effect here. This part will continue. Ux at x naught y naught plus vy, ivx I should say, at the same point x naught y naught, and plus this limit will be applied to the remaining part. So limit, and how the limit goes, delta x delta y tend to 0 0, and what you have inside is epsilon 1 plus I epsilon 3 into delta plus this particular, and this part is going to turn 0 as you are watching. This limit, again same kind of condition and same kind of thing over here carried forward. This we carry here. So what you observe, this goes to 0, this goes to 0, and this limit is equal to this value which already exists. Got my point?
Yes, ma'am.
So
Yes, ma'am.
left side I can say it is nothing but dw by dz by our notation, and right side becomes ux at that point plus I times vx at that point, means the derivative exists. Either you call it as ddz or you have another notation. What is that? F dash of z. Sure. So this way we say that the derivative exists. So how we started? We started with the fact that the first partial derivatives exist, they are continuous, they satisfy Cauchy-Riemann equations, and we went up to this particular. Is it fine?
Yes, ma'am.
So both the theorems are with you. Both are with you.
Yes.
Yes. So I would like to go ahead then. We have to clean the board. Yes. Now, the next part comes is, actually you have gone through when the function is differentiable and when not. Have to write the answer. In terms of polar coordinates even we have dealt with. You have to replace x as r cos theta and y as r sin theta and go accordingly. So Cauchy-Riemann equations in terms of polar coordinates are given here. R u r is v theta and u theta is nothing but minus r v r. So these are two equations you have to keep in mind. Whenever you go in polar, you have to use this, and in case of Cartesian, the things are quite easy. Okay, so if the things are given in terms of polar coordinates, you go with polar equations. That will be easy thing for us. So you can see over here, the function given is f of z equal to 1 by z. If you wish to use polar coordinates, you can write z as what? R e raised to I theta. I hope all of you are watching. Now, this 1 by r will be there, but e raised to I theta I can take to the numerator with index negated. Now, e raised to minus I theta I can write as cos theta minus I sin theta, as you are watching. And this is possible only if z is non-zero. If z happens to be 0, 1 by z will not exist. Now, what is the real part with me? It is cos theta upon r, that I call as u. And the imaginary part is v, that I call as minus sin theta upon r, coefficient of I. Fine?
Right, ma'am.
Yeah. Now, you have to differentiate this with respect to r. You want. So go with that. I think better if you take it in your hands. Come on, try to find out VR. Have you started? What will be UR? UR will be cos theta upon the derivative of 1 by r. What is it?
-1 upon r square.
Yes, it has to be minus 1 upon r square. Is it so? So when you take this r with this UR, it will be minus cos theta upon r. Got it?
Yes, ma'am.
And now you want u theta. So what will be u theta? Derivative of cos.
Minus sin theta.
Yes, it has to be minus sin theta upon r. It has to be minus sin theta upon r. So let us go with V. VR. What will be VR? So it has to be sin theta upon r square. And V theta. What will be V
Cos
theta?
theta upon r square.
Minus cos theta upon r.
R.
Is it right? So if you take this r up, you got RUR, and that value matches with this minus cos theta upon r, which is V theta. Followed? So you need to work in your notebook. If you work out it, the things are quite easy. Now U theta, it was minus sin theta upon r, and as far as VR is concerned, you can see there is no minus sign, and there is extra r in the denominator, so you can call it as RVR with minus sign. Got it?
Yes.
So these are the Cauchy-Riemann equations. And once you go with the Cauchy-Riemann equations, what you'll say, theta, as far as r and theta are concerned, these things will always exist. They are continuous. So first two conditions get satisfied. Question of Cauchy-Riemann just now we have shown. So third condition also is satisfied. So f dash z exists. Okay. And what is f dash of z? So according to that formula, you can watch here. What is the formula? E raised to minus I theta times UR plus IVR. So you have e raised to minus I theta times the thing. And ultimately, whenever you compute this, 1 by r square is there. There was minus sign, e raised to minus I theta. And this is again e raised to minus I theta. So it makes it e raised to minus twice I theta. Going down, you can make it up as what? Minus sign 1 upon r into e raised to I theta bracket square. So it is minus 1 by z square. And I think this we have done in our classwork also. Have we?
Yes, ma'am.
So this was just a kind of rewinding. Hope the thing is familiar to you. Now, if I go to the next example, it was cube root of r, and I think I have given this as a homework to you. This was cube root of r e raised to I theta by 3. And question says to show that when alpha is a fixed real number, the function has a derivative everywhere in its domain of definition. So again we have to show that it satisfies all the three conditions. So we mentioned what is our u, because what will be our function then? Cube root of r is there, no doubt. So r raised to 3 by 2, can I say? Cube root 1/3, no? I'm sorry.
Yes,
R
ma'am.
raised to 1/3. And in the bracket, what I'll write is cos of theta by 3 plus I
Plus
times
sine of
sine
I
of,
sine of
yes,
theta by.
theta by
Theta.
3. So you are watching, your u is cube root of r cos of theta by 3 and v is sine, is it? Now you go for what will be ur, vr, we have to differentiate the things. So what will be ur then? It is cube root. So 1/3 as the coefficient, है ना? And r will be raised to what? 1/3 minus 1, so minus 2 by 3. Is it fine? Into cos theta by 3 as it is. So instead of adapting this notation, let us go with this one. R raised to 1/3. So 1/3 comes down and r gets raised to 1/3 minus 1, that is minus 2/3. Are you getting me?
Yes, ma'am.
And what our equation requires is u r to be multiplied by r. So let me multiply throughout by r. What will happen? R u r will be equal to 1/3 is there. And we are multiplying by r means addition of the indices 1 and minus 2 by 3. So 1 minus 2 by 3 is 1/3. So I'll get this as r raised to 1/3 into cos of theta by 3. Followed?
Yes, ma'am.
Now go with now this v. What will be vr? Vr will be again on the same lines, 1/3 out, r raised to minus 2/3 sine of theta by 3. Sure, same kind of thing, there is no change. So rvr will be 1/3 r raised to 1/3 sine of theta by 3. Now let us go with derivatives with respect to theta. If I go with v theta here, I would like to continue with v theta. So if I go with v theta, what will happen? It is r raised to 1/3 as it is. And derivative of sine is what? Cos theta by 3 into 1/3. So upon 3. So these two tally. So r u r is v theta. Followed?
Yes, ma'am.
And go for u theta now. If you go for u theta, this being cos, thing will be minus. R raised to 1/3 is there, no doubt, into sine of theta by 3. And talking of theta by 3, there will be 1/3 out. So what you find is this r here is negative of u theta. Is it fine? So the
Yes, ma'am.
Cauchy Riemann equations get satisfied here.
That.
And then you need to write the derivative. What will be the derivative then? F dash z. It will be e raised to minus I theta out And inside what you'll write? UR plus I VR, is
I
it?
sin VR.
So UR is again on the same lines, one third let me take out. I would like to take one third out. This will be R raised to minus 2/3 cos theta by 3. And this will be plus I times R raised to minus 2/3 and
Sin
sine of
theta.
theta by 3. Now, if you take R raised to minus 2/3 out, it will be there. So it is R raised to minus 2/3 upon 3 is there. E raised to minus I theta is there, no doubt. And inside, this will be cos theta by 3 plus I sin theta by 3, meaning E raised to I theta by 3. So this is 1 theta by 3. And from that you are subtracting minus 1. 1/3 minus 1 means minus 2 by 3. So very directly you are getting R raised to minus 2 by 3 into E raised to minus it is minus I times 2 theta by 3 and upon 3. Followed?
Yes, ma'am.
Yes.
So this way you have to calculate. So they have given the derivative here in the same language, only the thing they have carried to the denominator. This is R raised to 1/3, this is E raised to I theta by 3 and they are squaring it. Whereas we have written it as R raised to 2/3, E raised to I times 2 theta by 3 and that was in the numerator with minus sign. They have carried it down and now they are calling it as thrice f of z and square. This is in the denominator. Okay, so whatever we use in our functions of real variables, same kind of thing you'll observe in case of complex variables also, as far as the formulae for derivatives are concerned. Sure. So I would like you people to solve the first two questions today itself, and if there is any doubt you'll ask me. Just take a screenshot of this immediately. Have you got what to do? See, in the first question, go for f of z equal to z bar. Z bar means it is x minus iy. So you'll come to know what is your u, what is your v. Accordingly, you go with. This is z minus z bar. So write z as x plus iy, accordingly z bar. Collect u, collect v, and show that the Cauchy-Riemann equations fail. Same here. Are you getting me?
Yes,
Yes,
ma'am.
ma'am.
So hope you'll try to do it.
Yes, ma'am.
Okay, talking of the second question, you can see to show that f dash z and second derivative f double dash z exist everywhere. So what you will do is first you will find out f dash z. For that you need to use your sufficient conditions, means three conditions you have to mention. Show that this is my f dash z. Again see what is the real part, what is the imaginary part. Again go with all the three conditions repeated and go for f double dash of z. And these two questions you'll solve in a notebook and post in our WhatsApp group. Is it okay?
Yes, ma'am.
Okay, so
Yes, ma'am.
immediately after this lecture, because less than 1 minute is there, So immediately after this lecture, you'll put it on our WhatsApp group. Solve it.